part of the Midnight Project, this is an interview talking about COVID-19 myths and truths. With us, we have Dr. Miftani Bieri. She is an assistant professor of human physiology in the Department of Life and Health Sciences of the University of Nicosia. She will help us, she will answer questions that many of us have regarding this pandemic that we're going through, and there's many things that are bouncing in our heads. So we will try to bring up the most common myths about COVID-19, and let's see if things clear in our minds.
Thank you, Anna. Thank you. It's a joy to be with you today.
So I will get right to the questions. A big one is that COVID-19 was created in a lab and then intentionally spread out to the world. Sinister purpose.
Okay, so this is an interesting idea. Indeed, it's something that has been going around mostly in social media. So let me start by saying that identifying the origins of the SARS-CoV-2 virus is really, really important. It's really important from a scientific perspective. So scientists are still looking into the origin of the SARS-CoV-2 virus. What they do know is that it's quite unlikely that someone created the virus in a lab. The reason we believe that it's highly unlikely, it's because we very quickly in this pandemic, we had the sequence of the virus. The sequence means the genome, so it's RNA, the letters that consist is genome. And scientists all over the world can study those letters that belong to the virus, and they can understand, or let's say they can have a good idea if this virus was created in a lab using a process of genetic engineering, or if it's a virus that evolved from another virus. Based on the studies on other coronaviruses as well, we think that this virus might have started in bats as a species and then evolved to infect humans, probably through another organism between the bats and the humans, but we still haven't identified which. It could be the pangolin, it could be something else. So the truth is that indeed we don't know the details, and there's quite a lot of a great part of the scientific community searching for the origins, because as I said, it's really important to understand where it came from. This is going to help us, first of all, not only from a scientific point of view, but from an actual, policy making. In a sense, we will try not to allow for this thing to happen again. Now, there's obviously, even if we don't think it's likely for an intentional genetic engineering, creation of a virus in a lab. Another unlikely option, but maybe a bit more likely than the genetic engineering, is that it got leaked from a lab. So there are quite a lot of labs around the world, not a lot, but there are some labs around the world, including laboratories in Wuhan, where the pandemic started from, where they do study viruses. And in Wuhan specifically, they do study coronavirus. This is not something that should surprise us, because in places where you can find these viruses, it's normal for the scientists to study them. It's the same reason, for example, that, I don't know, in Naples, in Italy, you have all these laboratories that do volcanology. They study the volcano. Why? Because there's a volcano. Yeah, so it makes sense. So we shouldn't worry about the fact that there's a lab in Wuhan that studies coronaviruses, but this could mean that until we know, it might as well be a virus that was in nature. The scientists picked it up from nature, and then it leaked from the lab. But I think from what I have read, this is not the most likely scenario. The most likely scenario is that in places where you have animals being in real contact with humans, and quite a lot of humans, like those food markets in Wuhan, there's a high probability possibility that a virus from the bats managed to jump into another species and then from there maybe to humans. But the short answer from this long answer I gave is that we really don't know yet, but it doesn't seem to be, I don't think we should worry about being a genetically engineered virus that was created to be used as a weapon. I don't think this is a likely explanation. Yeah.
But even the fact that it wasn't intentional, it came from nature, it's still not comforting because it could happen again at any time.
Yes, so, well, now I'm not sure if this is the answer you're looking for, but we have to be honest that viruses and bacteria have been on this planet millions of years before humans arrived on the planet, not evolved on the planet. And we have been living with these organisms for many years now. In fact, it's interesting how part of our genome is, if you read the human genome, you will find viruses that have integrated into the human genome. And that's another very interesting story. So indeed, we live with these organisms, and pandemics can take place. In the old days when humans, Homo sapiens on the planet, they were not so interconnected. Pandemics were a little bit more they would stay in one particular place, but now we're so interconnected. So it makes sense that you get a pathogen starting in one part of the world and then spreading everywhere. Well, we have to learn from this pandemic, hopefully, and evolve ways, find ways not to let it happen again. Well, us as a species, Homo sapiens, our strongest weapon is our intelligence, and the fact that we can foresee in the future, so we can expect another pandemic and we can prepare for it. So if we're really a really intelligent species, then this is what we should do so that we don't get another pandemic. And it could be the flu, it could be another strain, a different virus, it could be a bacterium, all those bacteria that could evolve, really high, that they don't have any issues getting away from our antibacterial substances. So we have to prepare ourselves from the next pandemic. Mm-hmm.
Okay. Next question that I have is that vaccines will make us sick with COVID, since they
so this is the myth made
coronavirus in them, so if I take it I'll become sick.
I see. Yes. Okay. So this is actually, I do understand the worry. Some people think that getting a vaccine, getting vaccinated, might give you the actual disease. Yep. So if you get a COVID-19 vaccine, you might go down with the disease. Okay. So this is, I understand the worry. The answer is no. So there is no way that getting vaccination will give you the actual disease. And the reason is that, let me focus on the vaccines that have been approved in Europe, even though this goes for all vaccines. So in Europe, we have two main platforms. One is the mRNA-based vaccines, and the other one are the adenoviral, recombinant adenoviral vaccines. So in simple words, we have the mRNA and the DNA vaccines. The DNA are the Johnson and the AstraZeneca, and the mRNA are the Pfizer and the Moderna vaccines, these four. So none of these technologies give you the whole virus. All they do is they give you a little piece of nucleic acid, DNA or RNA. So that little piece is injected into your body, and that gives information.
RNA of what?
Sorry?
It gives you DNA or RNA of what?
Of what? So it's part of the virus, but it's just a small piece of the virus, and specifically the part that the virus uses in order to enter our cells and infect us. That part of the virus is called the spike protein of the virus. So these vaccines give you the sequence, so the code the recipe, okay, in order for your body, your own cells, to create this little piece of the virus called the spike protein. Okay, so it's almost like a recipe book is given to you, and then your own cells produce this little piece of the virus. So your body never comes in contact with the actual pathogen. It's just information of a specific protein, so that what you want is for your immune system to see that protein that you made from the recipe that the vaccine gave you. So you want your immune system to see that protein and then prepare an army against that protein. Okay, and then the best thing about it is that not only creates an army that's going to help you, in the next weeks, but some cells that we call memory cells, they take that information and they can stick around for a long, long time. We don't know how long. We're pretty sure that definitely for 6-7 months. We don't know yet for these vaccines. So for other vaccines that we have, this immunity, these beta cells, they can stick around for years and years. And that's why sometimes, you can have a vaccine and then be protected for 20 years or 25 years. So we still don't know for the COVID-19 vaccines, but definitely vaccination is not going to give you, these vaccines don't even give you the virus itself, because other vaccines can give you the actual virus after they have killed the virus. So imagine it this way, or parts of the protein of the virus, or a virus that's inactivated in some way. These vaccines, the mRNA and the DNA ones, they don't even give you the whole thing. They just give you a tiny little bit of information.
So since it's just a tiny piece of the virus, it doesn't have all the information of the virus to...
It doesn't, but it has the specific part that scientists believe, based on research, that is the most important thing, so that you can create an army against. Yes, so it's the part that the virus uses to infect the cells. So this virus uses this spike, this little flag thing that it has, to imagine it like a key and a lock. So the key is the spike protein, and the lock are this specific protein that we have in our cells called the ACE2, the ACE2 receptors. Imagine it like a lock where this key binds nicely into it, and the virus uses this thing to unlock our cells and get inside our cells.
Mm.
Mm-hmm.
Okay. We won't get sick with COVID if we put the vaccine. However, I might not be able to get pregnant. Isn't it better to be safe than risk this?
Okay, so this is a very good question, or anyway, a very sad myth that circulates mostly in social media. And I find this particular, this particular fake news, because indeed it's fake news, I find it really tragic, because it's, the issue of fertility is very important, obviously, to lots of people, including women, mostly women, because the infertility myth and COVID vaccinations mostly targets women. So this started, I'll give a bit of information. It started from two scientists that said sent a letter to Pfizer claiming that the sequence of the spike protein, the protein that, as we said, is the protein that those vaccines target. Okay, so the idea for these vaccines is we create antibodies, soldiers against that spike protein. And these two researchers claimed that that protein, the virus spike protein, is very similar to a protein, a human protein that gets expressed in the placenta. That protein is called syncytin. It doesn't matter what it's called. The important thing to remember is that the claim was that there is the similar sequence, letters, similar between a human protein that gets expressed in the placenta, and we really need that protein in order for pregnancy to evolve in a nice way, in a safe way, and this spike protein of the virus. So you can understand that if this was true, then it could make a sense, and it could be a possible mechanism by which the vaccines they would try to target, they would try to fight the virus, and they would do this off-target effect on a specific human protein, causing, effects that you don't want. Now, what's the truth behind that? The truth is that as soon as this hypothesis came out, laboratories and scientists around the world tried to check those data. And that's something which is very easy to do, by the way. My students at the university do this type of analysis. It's called the BLAST. We can very easily get into the databases and find the sequence of the spike protein, find the sequence of this particular protein, and then match them and see, oh, do they match? Do they have a similarity? So the result was overwhelmingly that there's absolutely no similarity. So imagine, if I can give you an analogy, imagine it's almost like you and me share one digit in our phone number. Yeah, so I have number 7 and you have number 7 as well. But antibodies against proteins don't work like this. Antibodies are very specific. They need to see the entire number, okay, of your entire phone number in order to attack, not just one digit, if I can use this analogy. So there's absolutely no truth in this. And even if there was truth, even if there was, at this point, with a vaccination of over reaching, 1 billion or even more, we would statistically start to see these infertility issues in the Homo sapiens population, which is not something that we see. Women get vaccinated, they can get pregnant, they're fine. There's no issue, and I really urge women that want to have babies to, exactly for this reason, to get vaccinated, because we're in the middle of a pandemic and this is the best way to protect themselves in order to have a safe and healthy pregnancy in the future.
Yes, okay, I understand how it doesn't affect pregnancy in the short term.
Fertility, yeah, or pregnancy, but okay.
However, in the long term, we don't know how our body will react to this virus, and not just for fertility, but for any condition.
Okay, Joanna, this is a very good question, and it's a very widespread worry about vaccines. So
people are trying to wait it out, see others would it wait a couple of years, and even that's not enough, but at least it's the minimum they can do before they feel safer in order to put the vaccine.
Yes. No, it's a very good point, but the answer is not that difficult. Okay, so the answer is that vaccines are drugs, and all drugs have side effects. So I think this is the first thing we should say and be clear and clear with people. So anything that has an action might have a bad reaction as well. Okay, anything that doesn't have a bad reaction usually doesn't have an action either. So all drugs do have, could have, and do have side effects. Now, vaccines are drugs that are given so acutely in 1, 2, or maybe 3 doses, or even, the flu vaccine once a year. But in general, they're not chronic drugs. So they're not drugs like, what should I say, the drugs that we take to lower blood pressure, or drugs that we take, so that we don't get pregnant, or all these drugs that we take every day, or for a long time. Those drugs might give you long-term side effects. Vaccines don't belong in this category, so they're given once, or in 2 doses or 3 doses, and what they do is that they activate your immune system. So you might get side effects. The good news is that they're very, very rare with the vaccines that we've seen now, the ones that have an approval by EMA in Europe. And the side effects, the serious ones, you can experience them very quickly. So in the first 20-25 minutes, anything that has to do with an allergic reaction. And then afterwards, anything, it's mostly in the first, all the way up to the first 2 months, which you might get an autoimmune trigger or something like that. But it's important to say that the pharmaceutical companies follow up when they did the clinical trials, they follow up people all the way up to 6 months. So more than the timeline that I just presented. And obviously, they keep continuing to making sure all the way up to 1 year. That's why Pfizer got the full approval for the vaccine after it presented to the FDA the data for a whole year. But there shouldn't be a worry. You know, obviously you understand that if something happens to you if you have a heart attack 5 years down the line, it's very difficult to connect that event to something that you did 5 years ago. And also as scientists, we cannot think of a mechanism that would wake up something 5 years or 10 years or 15 years down the line. So even though we always check for side effects of drugs for a long period, it always depends on the mechanism of action of the specific drug. And for vaccines, you do check them, but you check them for the time that you know and you believe that based on data and based on the previous knowledge, scientific knowledge, that this is the time window, the time frame that I expect to see some effects that I wouldn't like to have with this drug. So I'm not sure if I answered. So the question is that long-term effects are highly unlikely. I don't want to use the word, there's no way, but highly unlikely. It would be the first time we will have long-term effects for a vaccine. And there's one final thing I wanted to say here is that, the drug companies, they spend lots of time and money quickly making these vaccines. And I understand that people worry because of this time, how quickly they appeared. And I want to stress here that yes, indeed, they did appear quickly, but they weren't rushed in any way, okay? So that doesn't mean that the drugs, the vaccines are unsafe. So because of the global pandemic, the companies spent a lot of money, so money wasn't an issue, like the previous times that we tried to get a vaccine into the circulation, to give it to people. Money wasn't an issue. Bureaucracy wasn't an issue. So all bureaucratic procedures just very quickly, went out the window. And also, it's important to remember that for all the people, this mRNA technology just appeared out of nowhere. But for scientists working on mRNA, the science behind the vaccines has been out there for a long, long time, for over 20 years. So these companies or the laboratories, the Oxford lab, for example, that created the AstraZeneca vaccines, they have been working on these technologies for a long time, all the way from the MERS virus, the SARS-1 virus, and all they had to do now was to modify their platform, to modify their, the vehicles, as we say, that they use in order to match this new pathogen, SARS-CoV-2. So a lot of the work was done. And of course, the final thing, because we're in the middle of a pandemic, it was easy for the companies designing the clinical trials, phase 2 and 3, to find people, to find people, and those people, usually you want a lot of time for people to get infected, people in your control group and people in the group that got the vaccine, because in order to have data, robust data, you need your statistics to reach a certain amount of people. So this is something that sometimes you have to wait for lots and lots of months, even years, to reach those numbers. In this case, the scientists recruited people from Brazil, from the US, from places where, unfortunately for us, for the people, the pandemic was so active. But for the scientists, that was a good way because they quickly got the numbers back that they needed. So that was another way why, another reason why those clinical trials faster than usual gave us data. Okay, so please remember, definitely quickly. No one, I don't think at any other point in history had a vaccine coming out so soon, but at the same time, definitely not rushed.
Yes, so in that aspect, it's safe because everything that should have been done was available to be done sooner. I think many people think it's unsafe because of the length of time, the effect it will have after a long period of time, which wasn't able to be tested.
Yes, but as we said, you
said that there's no correlation between, as scientists know, between a vaccination and the long-term effect. So
it's highly unlikely.
There's no way that there could be a mutation or something that could bring.
Okay, so mutation. Now, let me try to phrase a question. If you get vaccinated against the SARS-CoV-2 virus, the initial vaccine, the vaccines were designed based on the initial strain of the virus. Yes, so the initial virus that was out there. From the beginning until now, viruses evolve, and the SARS-CoV-2 virus has evolved. In fact, evolved meaning accumulating mutations, so being a little bit different than the initial strain that we had. And it's interesting that if you go into the databases, you will see that we have thousands and thousands of different mutations onto the initial letters, the sequence of the virus. Now, some of these variants, as we call them, some of these viruses that are slightly different to the initial, to the mother virus, yeah, some of them are called VOCs, variants of concern. And why concern? Because some of these mutations are in this particular place where we targeted our vaccines, the spike protein. So if that key that unlocks the door lock, if that key changes a little bit, then it might escape the vaccines that we have designed. Okay. Now, the two things I would like to comment on here. One is that the variants that we have up to today, the Delta variant that you might have heard of, or the new variant, but especially the Delta, which seems to be, unfortunately, a variant of a version of the virus, which is highly contagious, more contagious, 5 to 6 times more than the initial one. Well, this variant seems that doesn't, the vaccines that we have, the science shows that the good news is that they can still give you really good protection from this particular variant. So at this point, we shouldn't worry yet. But this doesn't mean that we shouldn't worry in general, because for as long as the pandemic continues, and especially in places where there are a lot of people, like India or the US, or in places where there's a loss of, a lot of people, then we might have a new variant. And that new variant might escape our vaccines. Now, there's some good news here as well, and those are that this novel technology of vaccine, this new vaccine technology, the mRNA technology, some people call it, the digitalization of vaccines. And the reason is that you can very easily, or anyway, in an easier way, you can modify the vaccine in order to match the new variant, the new strain. And it's a little bit more complicated, but it starts with going to the computer, reading the new sequence, clicking Control F, going to the place where the mutation is, and Control Replace, and adding
Wow.
the new bit. That's why they call it, digital, like a new digital era of these vaccines. And I think this is brilliant. And I truly believe, that most vaccines might move, the future vaccines might move towards this technology, because it seems it's very safe, very efficient, and it provides you with this added benefit that as the pathogen changes, if it's a virus, if it's a bacterium, you can be there, change your vaccine and be ready to target the new variant.
Mm. So that means people who are already vaccinated, if there's a variant that escapes the vaccine, they should go get a new one.
Yes, they could have theoretically another dose with the second generation, the novel vaccine, that takes under account the fact that we have now 2 strains in the population, or 3. Or they could get a vaccine based on where they live, where that particular strain has taken over. But because we're so interconnected, and usually what you have is globally, give it enough time, globally one strain will take over. Look at what happened to the Delta strain. Mm-hmm.
So it's worldwidely spread, Delta.
That's what happens, yes. So a strain that's more contagious than another strain will slowly take over. And also there's something else which I think it's quite interesting and not a lot of people realize, and that's the fact that if you do get a strain which is deadlier, so it makes you more sick, if it makes you really more sick, then it doesn't have an advantage in a sense. People that might get the virus and get really sick and very quickly, they're going to stay in bed isolated, so they will not go around spreading the virus. The reason the SARS-CoV-2 virus became so successful is the fact that it had all these characteristics where it makes you sick, but not very sick. Also, you can carry it around being asymptomatic or with very little symptoms. So all these characteristics is what made it so successful in what it wants to do. Very
sneaky.
Yeah, exactly. Exactly.
So even if it evolves like the Delta that became more contagious, it evolves in order to be even more successful, right?
Well, no. In order to be correct, we shouldn't say that it evolves in order to be more successful. What happens is that it evolves by chance. So mutations are there by chance. There's not really that, the virus wants to do, it doesn't want to escape our vaccines, but by naturally, every time these pathogens divide, they make mistakes, and sometimes these mistakes might give you a new function, around the virus. So the way it works is that by chance you get these variants, and then some of these variants might be better than others, and then they're the ones that are going to stick around. But there's no actual, the virus cannot actively change itself to do something. Mm-hmm. Yeah.
Like it's got a mastermind to take over the world.
No. Evolution by itself, and yeah.
Does it?
Yeah.
Yes.
Mm-hmm.
Okay. So our goal for people to get vaccinated quickly is to reach herd immunity.
Oh, okay. So the term herd immunity is really interesting. So I'm sure it's a term that not a lot of people were familiar with before this pandemic hit us.
Yes, I even thought it they created it for this pandemic.
Oh no, it's a very well-known term in science, and it's, you know, it's the number where if enough people in a population have reached immunity, then you see slowly the virus not being successful anymore and the numbers going down. So if you have enough people that have developed antibodies and immunity against the pathogen, and that's why if a lot of people get vaccinated against a specific pathogen, then via herd immunity, we can help other people in the society that are vulnerable and that they cannot get vaccinated, because we always have a small amount, a small percentage of our population that cannot get vaccinated, or even if they do, they will not develop immunity. People that are immunocompromised, very young children, very, very old people. So these are populations that get protected within the society by the rest of us. And that's where we also, you know, we don't only get vaccinated to protect ourselves, but we also have, you know, we owe it to the society that we live in order to protect people that cannot get vaccinated or that will not develop immunity. Okay, so herd immunity is what happens when the population reaches a specific number. It's interesting how at the beginning of this pandemic, the goal was to be able at some point to reach herd immunity. Obviously, through that will happen through vaccinations. You can reach probably herd immunity by having the natural virus spreading in a community. But you have to remember that if people get immunity via the natural virus, the wild type, as it's called, virus, this is going to cost you lives. Yes, so for 70% of the population reaching immunity means that you will have lost thousands, if not more, people to the virus until you reach that. And this is the ethical issue here, that whereas if you use science and the science of vaccinations, then you reach herd immunity, hopefully, but without the cost in human lives. Now, I don't want to get too technical here, but I think that the data that we have now on this pandemic, on this virus, and on the vaccines that we have in hand right now, we're not sure if we will be able to totally get rid of the virus altogether. So immunologists and epidemiologists have different models for now, and they're not sure if we will manage to have what we call, you know, zero COVID and to totally forget this pathogen, or if we will find via vaccinations a way to live with the virus, to vaccinate the people that, you know, most of the population, and then slowly to also be able, hopefully, to find good drugs to deal with this virus, and hopefully find a way to go back to a normality and normal lives with the SARS-CoV-2 virus being around. I'm not sure what the answer is. Yeah.
To go back to a concert.
Yes, hopefully.
Close in the winter, that would be a relief. I was going to ask you about, many people think that it's not so serious to get COVID. It's not as dangerous as it's said. It's like a common flu, or even you're asymptomatic, and we shouldn't be worried. So just relax. And
okay, yes. So I wish COVID-19 was as simple as the flu. Unfortunately, it isn't. So the flu and COVID do have some things in common. So they have some symptoms in common of the respiratory system. They can, both diseases, you know, can cause pneumonia, and but COVID-19 is a different. and more we study it, the more we find out it's a different type of disease. It's more systematic disease. In a sense, it affects more than the respiratory system. So we know that it causes thrombosis. We know that it has effects on the central nervous system, on the brain, and more. So unfortunately, no, it's not like the flu. It's much more serious. It does spread more. It has an increased number of deaths, unfortunately, than the flu. And it's important to remember that at this stage, we still don't have, a specific drug for this disease. In the future, we will, hopefully. But at this point, we don't. And there's another really important, I think, difference between COVID and the flu. And this is the amount of time people actually spend in hospital and in the ICU, the intensive care units. So with COVID, it's a very, very long time that patients have to spend. Sometimes it can be months. That's why this particular disease is quite harsh on the health systems of the different countries. And this is the reason why we cannot just, say, well, it's just the flu and we're causing all this, mess for no reason. Unfortunately, there is a reason. Unfortunately, we have seen the bad face of this disease. We have seen what happened in Italy, in Bergamo, at the beginning of the pandemic. We have seen what happened in places like Brazil, where unfortunately the healthcare systems of those countries, they reached their limits, and we had people not getting the actual healthcare that they deserve to get.
Yes. When we were talking about herd immunity, I have this question about Israel. Israel reached the point we call but there was no herd immunity.
So, okay, the story,
makes
yes.
people suspicious still.
So
are making fun of, they don't know what they're telling us.
I think things are, it's not as simple as sometimes it spreads around social media. So indeed, Israel started very quickly with its vaccination program. And it became quite popular as well. Now, the actual numbers, I don't think will show you that the percentage of immunities is extremely high. So it definitely didn't reach the numbers where epidemiologists would want in order to reach herd immunity. And there are also some populations in Israel that were not vaccinated. But also this was before the Delta variant hit Israel. So as soon as this new variant came, and we know that vaccinated individuals do have a lower chance, but again, they can carry the virus, lower than the unvaccinated, but unfortunately, they can still carry the virus. The virus, the Delta strain, did spread. And also, I think in Israel, they quite quickly stopped the other measures. So having a vaccination program is very important, but at the same time, it's really important to give a balance between, your vaccination rates going up and all the other measures. So you should continue with the mask, you should continue keeping distances, and everything has to, you have to keep this balance. If you stop with the mask mandates and everything else without having reached a particular percentage, then you might see this increase in numbers. So what I'm trying to say is that some of the data we get from Israel, seeing the positive people positive on COVID going up, it does have an explanation, but it's really important to see also the numbers that have to do with serious disease and deaths. And it's very clear how vaccination protects us from serious disease. It protects us from dying, which is the most important thing. And looking at the data in Israel and in other places should make people feel a little bit more safe in order to have the vaccine.
Mm. So we should have all of the data out, not just, we should also see how serious people are getting sick in Israel, not just the fact that there's still COVID there.
Yeah, I mean, the important thing is not to get people that are positive. I mean, obviously you need that number as well, but it's the people that are getting sick and the people are getting in hospitals, people get hospitalized, and obviously deaths. And I repeat, this is something that the vaccine has showed us that can really protect us from.
It does its work.
Yeah.
It does its job.
Mm-hmm.
Okay. I wanted to ask about the hype, the bad rep AstraZeneca got.
Okay.
People were very afraid.
Okay. Well, I think, again, it's important to underline that all vaccines, all 4 vaccines that have been approved by the European Medicine Agency, the EMA, which is a very, very, how should I say, strict regulatory body, okay? It's a body that wouldn't allow for these vaccines to be out in circulation if the benefits didn't outweigh the risks. Okay, so this is the first thing we really have to remember. Now, are there risks? Yes, there are. Are they common? No, they're not. The AstraZeneca vaccine was also a little bit, I think, what's the word? It was a vaccine that, because it was the first to came out and to apply for from the regulatory bodies for approval, and because we all together, you know, the whole population, we witnessed how there were pauses on the vaccine because of some adverse effects that were identified in some people. So that kind of created an extra, I think, worry to the population. Now, if you see the actual numbers, though, which is what the regulatory bodies do, you will see that, yes, it has been linked to a very serious, or it could be serious side effect, this VITT syndrome, which is a thrombotic syndrome of autoimmune nature. So your immune system tends to cause these adverse reactions. The important thing is that we have now identified it. It has been noted, and the healthcare providers should watch for it, and the people that have a vaccine, they should be able to determine if they have particular symptoms. They should be able to identify and get quickly, get all the help they can. Now, again, the important thing to remember is that this is something which is rare. It's not something that happens, definitely not as, I don't remember the exact numbers, but it's a rare event, and it's something that, again, the benefits of getting vaccinated outweigh this risk. We are in the middle of the pandemic, and we should definitely not forget the risk of thrombosis and of all these other symptoms and effects we might get if we get infected with the actual wild-type virus.
It's more dangerous.
Of course.
If you're susceptible.
Well, we're not even sure. We know that people that are susceptible, older individuals, people that have other issues, obesity, heart disease, specific issues, they tend to be more susceptible. But we do see some real adverse effects on, some real pathology on young people. It's very rare, but we even see it with children. And I think this is something that should worry us. We shouldn't think that COVID-19 is a disease only for the older generation, and if we are young and athletic, we think that it doesn't concern us. Unfortunately, it does concern us, and there are some young, healthy individuals that have had a really bad prognosis, bad outcomes. And sometimes it is because they have, sometimes it's because their immune system kind of went into override due to the virus, and then gave them all these adverse and really serious pathology.
From what age can children get vaccinated?
At this point, the EMA regulatory body has approved the mRNA vaccines over the age of 12.
Mm-hmm.
Mm-hmm.
Okay.
And I recently saw that, I think a few days ago, Pfizer finished a clinical trial on children age 5 to 12. I think it concerned around 2,000 or 3,000 children, 5 to 12, and they plan in the next few days, weeks, to submit those data to the FDA to see if they can get approval for the younger children. But this age group doesn't have approval yet. So approval we have over the age of 12 for the mRNA vaccines. Mm-hmm.
And one last question.
Sure.
If I get COVID-19, if I'm infected, I get over it, am I immune? If not for life, for 6 months?
That's again a very good question, and it's a question that I know it's a question that a lot of people ask, and there's again a lot of misinformation around it. So it's funny how I've been reading in various media, social media, or other platforms that once you get the wild type virus, you're immune for life. So the answer is we don't know if you're immune for life. No one can tell you for sure at this point. We don't know how long it lasts. There are data coming out, and there was a very interesting paper from Israel, in fact, that showed that people that got infected versus people that got vaccinated, how they were better protected. But this is one. This was one publication. I'm not even sure if it was a preprint, as we call it, so not peer-reviewed yet. But it did cause quite a lot of interest. But the truth is that there are other data out there that show increased antibodies in double vaccinated people with the mRNA vaccines versus people that have had the disease. Again, we're not sure what, if you see high antibodies, again, you're not sure how protected you are. So there are a lot of unknowns, and I think at this stage, it's more important to accept and admit there's still things that we don't know, we're not sure about, the scientific community is not sure about, and we're really researching these things. But at this stage, we cannot say for sure. So we can say that the vaccines we have are very good 7 months after the initial dose. They still immunity does wane a bit, goes down, but we're still very well protected. With people that have had the disease, again, we see some sort of immunity, but then again, it's a little bit of a slippery slide in a sense. What does it mean I had COVID? Does it mean I was tested positive and have had, a symptom of not being able to smell or taste for a little bit? Or does it mean that I had serious disease that put me in bed? So it's a spectrum, and we're not sure, if the really people that went through the disease in a really light way, do they get the same immunity with people that had to be hospitalized, for example? So all these things are things that we're rigorously researching. But I think the most honest thing to do is to say that we're still not sure at this point.
Okay. Well, yes.
And I would like to, as a maybe final point, I think it's really important to remember that this is a pandemic. This is, I mean, a global effect, something that has affected the entire planet and Homo sapiens living on the planet. And it's really important to tackle this pandemic for what it is, a global thing. So we have to think about, when we start thinking about third doses of vaccines, for the whole of the population, we have to always remember that there are places around the world that haven't even had one dose of the vaccine. And that's why the WHO, the World Health Organization, keeps reminding us of this, keeps telling us how all countries together should work together and to tackle this issue for what it is, a global issue, an issue that affects the entire of the Homo sapiens population, and not just the rich countries, but everyone.
Yes, the chance for us to come together.
Exactly.
And work for a common goal.
Exactly.
By being humane, by thinking of others as well as ourselves. So at least if this could come out of it, that would be something.
Excellent.
So yes, you've dispelled the myths that I had in my head.
I hope it helped a little bit.
Yes, I hope the rest of watching this will get clarity. Is there anything else you would like to add?
No, that's fine. Thank you so much, Jana. It was great talking to you.
And thank you.
Thank you. Bye. Bye.